Hello all, my name is Isra Khan and I'm here to teach you guys chemistry 5070. Let's begin with today's topic. So today we're going to start with the particulate nature of matter 2.4, which is going to be ionic bonding as we discussed before as well. That now I'm going to continue with the bonding. So let's begin. The first one is ionic bonding, and today's learning objectives are going to be that we're going to learn about the formation of the ions in order to obtain the electronic configuration of an inert gas. We're also going to learn about the formation of ionic bonds between the metals and the non-metals, and we're going to learn about the ionic lattices and what are the physical properties of the ionic compounds according to the lattice structure. Let's begin. First of all, any atom has whatever the electrons they have in their outermost shell are those electrons which are involved in a chemical reaction. So only the outermost shell electrons, or known as the valence electrons, they will be involved in a chemical reaction. The other electrons which are present within the pre shells, which are before the outermost shell, are those electrons which are known as the core electrons. They do not play any part in the chemical reaction. So only those electrons which are um, involved in a chemical reaction are the outermost shell electrons. So only the outermost shell electrons will either be transferred or they will be shared whenever they have to attain a noble gas configuration. Now, in one of my lectures, I told you guys that what is a noble gas configuration? A noble gas configuration is a configuration um, which is either duplet or it's going to be octet. So any atom which does not has either two electrons in the outermost shell or does not has up to 8 electrons in the outermost shell, they do not attain a stable configuration. So they need to have either of these two. Mostly each shell they can have 8 electrons in their shells. So they need to have this octet configuration to attain this noble gas configuration so that they are stable. When they're stable, they will be only involved in very few reactions or not or no reactions mostly. So because they're stable, they don't need to react to any other atom to attain a noble gas configuration. So this is why the bonds they are basically formed, and that is the reason only the valence electrons, which those electrons which are in the outermost shell, they are involved in the formation of these chemical bonds. And these valence electrons, the number of the valence electrons, which is basically the group which I told you guys, that the valence electrons in the outermost shell tells us the group of that element. In which group is it present? Is it present in group 1 till 8? And then this is going to tell us the chemical properties of that element. Right. So the valence electrons, this is the importance of the valence electrons. Okay. And this is how the bonds they are formed because of the transfer of these valence electrons. If you talk about, because today's topic is ionic bonding, so if I talk about ionic bonds in ionic bonds, the electrons, these electrons, valence electrons, they are transferred between the atoms. Okay. So when they are transferred, these transferring of the electrons between the atoms, this is known as ionization. This is known as ionization because it is the formation of the ions when the electrons are transferred between the atoms. They are either cations are formed or anions are formed depending on the transfer rate. For example, when an atom is neutral, an atom is neutral. It has similar number of protons. See, you see three protons present inside the nucleus, and it has three electrons. So all the positive and the negative charges, they are balanced, right? But when it is going to lose its electron, when it is going to lose its electron, the electron carries a negative charge. That is why it is written like this. We are going to have three protons still inside the nucleus, but now because it has lost one electron, so now it has become two electrons in the outer shell. So this means that we have plus one extra charge on this ion. This is the reason it is known as a cation or a positively charged ion, because it has more positive charges as compared to negative charges. However, if I talk about anions, in anions, you see here it remains the same, three protons inside the nucleus and three electrons outside. So positive and negative charges, they are balanced. That is why an atom is neutral. And when they're going to gain an electron, they are going to become four electrons in the outermost shell. So you see only the outermost shell is shown in the diagrams. And why is that so? For convenience. You cannot draw so many shells. If so, for example, um, it is in the seventh period and you have to draw seven shells, so that is very difficult, which is why only the outermost shell is represented. So it still has three protons inside. So this means three positive charges and four negative charges, which means one extra negative charge. So one extra negative charge is going to give it minus one charge. If it's going to be two extra negative charges, it's going to become minus two. If it's going to be three extra negative charges, it's going to become minus three. And same goes here as well. Plus 1, plus 2, plus 3, depending on the number of electrons lost and depending on the number of electrons gained. So an anion is an ion which is negatively charged. Okay? It is negatively charged. Right. So when an atom loses electrons, it's a cation. When it gains an electron, it's an anion. Positive charged cation, negative charged anions. Okay. Now coming back to the next slide. So here, the force of attraction which holds two or more atoms or ions or molecules in a bond, that is known as a chemical bond, and there are different types of bonding. We have ionic, covalent, and metallic. So ionic bonding is the bonding where the electrons, they are transferred between two atoms. Covalent bonding involves the sharing of the electrons, as you can see over here. The electrons, they are shared. However, the electrons in ionic bonding, they are transferred here. And ions are formed. In metallic bonding, you see sea of electrons which are arranged in between the positive ions. Right. Now, this I have shared earlier in my first slide as well, that the atoms, they, if they do not have the noble gas configuration, which is either 2 or 8 electrons in the valence shell, they are not complete and they are unstable. So to get this 8 electrons, they become complete, and then they will not react with other atoms, and they will not react because they are now stable, right? This is why we call the group 8 elements the noble gases, because they are stable and they have 8 electrons in their outer valence shell. So other atoms, they react with each other, and then that is the reason they form bonds. They share or lose or gain electrons. And metals, they lose their electrons, they form cations. The metals which are present on the left hand side of the periodic table, this side, right? So this side is for metals, this side is for non-metals. The left hand side is for metals, and they are going to lose electrons to form cations. So why is that so? Why is that so? This is because metals, they only have usually one electron or two electrons or three electrons in their outer valence shell. So it is much more easier for them to lose the electrons, whereas to gain the electrons. So non-metals, which are on the right hand side, they have usually 6, 7, and 8, 5, 6, 7, and 8, right? Electrons in their outer valence shell. So it's much more easier for the non-metals to gain the electrons as compared to losing their 5 or 6 electrons. Much difficult for them. That is why they gain the electrons, which is much more easier. So you see, if they have 7 electrons in their outermost shell, they just have to gain 1 electron, and they will get the noble gas configuration, which is 8 electrons. If it's 6 electrons in the outermost shell, they will just gain 2 electrons, and then they will they will get 8 electrons in their valence shell. Same goes here for the metals. If the metals, they have one electron, they will just lose 1 electron, and it will get the noble gas configuration. The previous cell already has 8 electrons, right? And if it's 2 electrons, this is just going to lose its 2 electrons to get the noble gas configuration. So this is how chemical bonds, they are formed, where the electrons, they are transferred or they are shared, and this is known as chemical bonding, right? Now coming to my next slide. Now I'm going to discuss that how the ionic bonds are formed between the metals and the non-metals. Now I already discussed the metals are on the left hand side of the periodic table and non-metals are on the right hand side of the periodic table. Metals, they form positively charged metallic ions, whereas non-metals, they form negatively charged uh, non-metallic ions. And there is an electrostatic force of attraction, of course, between them because of these charges, positive and negative charges, which is why they form an ionic bond. So you see, for example, sodium Na is in group 1 and chlorine is in group 7. So it only has to lose its 1 electron. So it's just going to transfer its 1 electron to chlorine. Now you see, this is a dot and cross diagram. Dot and cross diagram is self-explanatory. Now you see, dots are representing one atom's electrons, outer electrons only. So I'm only going to talk about the outer electrons because they are only involved in the chemical bonding. Okay. This is the reason only the outer electrons of the valence shell is represented. and that is the reason not other shells are shown or represented over here in this diagram. So only the outer electrons, which are represented here by dots, and the other electron, the other atom has its electrons represented by an X. So dots and crosses. So these are transferred, and when they're transferred, the atoms, they are going to automatically become ions. Sodium has lost its one electron because it was in group 1, so it has one valence electron, whereas chlorine has 7 valence electrons because it is in group 7 of the periodic table. 1, 2, 3, 4, 5, 6, 7. So it's just going to transfer, sodium is just going to transfer or lose its one electron, and chlorine is just going to gain one electron. So now chlorine has an extra electron, so that is why it's going to get minus charge, and sodium has now lost its electron and it has gained its noble gas configuration, so it has lost one electron. This has gained one electron and this has lost one electron. So that is why now losing one electron is going to become less negative charges. This is why more positive charges because of the protons. So this is now going to become a cation and chlorine is going to become an anion. So because of this development of the ions, there is going to be an electrostatic force of attraction, which is why now these positive and negative charges, they attract towards each other. So there's going to be an electrostatic force of attraction, and they both are going to create an ionic bond. Now you see over here, it's much more clear. So sodium has now in this picture you see that all the shells, they are represented. They are created here. So, but this is very difficult. This is why in talking across diagrams, only the outer shells, they are created. So only for herpes. So sodium has transferred one electron to chlorine. So now you see that the outer shell is gone. There is no outer shell. This is the reason we have only 2 shells left, and the previous shell has 8 electrons already. This is why sodium has now got an noble gas structure or noble gas configuration, which is octet configuration, 8 electrons in the outer shell. And now even the chlorine has octet configuration in its outer shell, 1, 2, 3, 4, 5, 6, 7, 8, by gaining one electron from sodium. So sodium plus and chlorine minus. This is how the ions will be formed, and an ion bond is formed, created. Yeah. Let me come to my next slide. Now this is we already now get this how Dutton cross diagrams, they are created, and how the transferring of electrons happens in an ionic compound. Now you see that ionic compound, when they are formed, they have a chemical formula, and they are represented by their chemical formulas. They are written as symbols of the atoms which are present in an ionic compound. For example, if I have X and Y as a compound, so X has certain number of okay, one more thing, always the metals, they are going to come first in an ionic compound when you are going to name them. So it's always going to be sodium chloride, right? And Na is always written first because it is a metal. So this is a metal, Na is going to come first, its symbol is going to come first, and when you're going to name it, it's also going to come first, sodium chloride. And non-metal is always written after the metal. So it has positive charges, metallic ions, they are going to form cations, non-metallic are going to form anions. That is why this one is going to have a negative charge. And when you're going to irrigate its formula, how is it going to occur? This is going to be the derivation. Now X gets this number as a subscript on its right hand side just beside the atom. So X and will get the number of charges from Y, so it's Xn, and Y will get the number of charges from X, so it's going to be Ym. Okay, so it's just going to be cross in this cross direction. Whereas if you get a subscript which is one, only like for example in sodium chloride, only one electron is being transferred. So one is not usually written in the formula. Okay. However, if there is something else, for example, if it's magnesium oxide, now magnesium oxide, you see magnesium oxide has magnesium has 2 plus, and oxygen has is in group 6, so it is going to gain 2 electrons. So if it's going to come down and down, so they both have equal number of electrons being transferred, so they will just cancel, and it's going to be MgO. However, if we have any other, for example, if you have Pb, lead chloride, lead 2 chloride, it's 2 plus, and chlorine is because it is chloride ion is minus, so minus 1. So what's going to happen? It's going to come here and it's going to go there as a subscript. Then it will form Pb, and 1 is not usually not written as a subscript, so I'm not going to write it over here, but Cl, and then 2 is going to come over here as a subscript just beside chlorine. So it's going to be PbCl2, right? Okay. So this is one more example. So I've shared about 3 examples here with you guys. And one more thing. If you have more than one atoms in an ionic compound, for example, it's going to be polyatomic ions. Polyatomic means more than one atoms in an ionic compound. So they are going to be written within the brackets. For example, it's going to be copper. Copper is over here, it's 2 plus, and hydroxide ion carries negative charge, so it's going to come within the brackets, and then you're going to, it's minus 1. Okay, so now you're going to just transfer the charges, and then it's going to become Cu. So 1 does not come as a subscript, so I'm not going to write here 1, and then OH will come within the brackets, which is the hydroxide ion, and then 2 is going to come over here as a subscript, right? So this is how you form or derive the formulas for an ionic compound. Okay, so let's come on to the next slide now. Now I'm going to share with you what is an ionic lattice. Now ionic lattices, they are the structure of the ionic compound which has been formed. Now you see this is a sodium chloride lattice, NaCl. So both are in the ratio 1:1. One atom of sodium and one atom of chlorine. So the nearest neighbors to this chloride atoms, if this is chloride atom, if this is iodine, sorry, and this is sodium cation, and they're represented by their blue and green dots. So this has 6 sodium ions surrounding it. And this sodium chloride is the ionic compounds, they always form a giant ionic lattice. Okay, and it's always going to be in an organized manner, as you can see over here in this diagram. The ratio is given, and it can be deduced from the formula as well. This is NaCl. This will be known as the formula unit. This is known as the formula unit. And the oppositely charged ions of the sodium and chloride, they're so attracted to each other, so strongly attracted to each other that they're going to form this giant ionic lattice. Same goes with MgO2, if it's MgO2. And so what am I going to say? That it's going to be 1 ratio 2, right? So this is going to form a giant ionic lattice, and this is how the structure of an ionic compound looks like. Now coming to my next slide, this is these two slides are related because from this lattice structure, I'm going to tell you how you can um, think of the physical properties of the ionic compounds. So all the ionic compounds, they have this giant lattice structure, which is why they have a strong electrostatic force of attraction between them because of the oppositely charged ions. And this is the reason that at room temperature and pressure at RTP, they are going to be solids because of this strong electrostatic force of attraction. They are also non-volatile and they will dissolve in water. For example, sodium chloride is a common solvent, and when you're going to dissolve it in water, it's going to be soluble. So they are soluble in water, but however, if you're going to dissolve it in organic solvents such as ethanol or petrol, they will not dissolve in in organic solvents. So they are basically insoluble. The exception to these ionic compounds here is this is an important point that silver chloride AgCl and barium sulfate, they both do not dissolve in water. This is an exception. Okay. So this is a very important point that you guys should remember. Okay, because the electrostatic forces of attraction are greater in between the atoms or in between the ions of this in an ionic compound in an ionic lattice. So this is the reason that they have higher boiling points and higher melting points both. Because only because of the strong electrostatic forces of attraction. Lots and lots of energy is required to lots and lots of energy is required to break their their bonds, which is why higher boiling point and higher melting point. All right. If they are in a solid state, they are not going to conduct electricity. Why? Because no free moving electrons. But they can conduct electricity if um, they can conduct electricity if they are in molten state or they are in aqueous state. So in molten state, what is going to occur? In molten state, the metals or whatever the ions they are just going to they're just going to have the free moving electrons. So when they have the free moving electrons, they will be able to conduct electricity. And same goes over here in the aqueous solution. When they're going to dissolve in water, they're just going to ionize. When they're going to ionize, they will have free moving electrons as well. So they will be able to conduct electricity in an aqueous solution as well. In solid state, the ions they are so tightly packed and they are so tightly intact with each other that they do not have any free moving ions, which is why free moving ions or free moving electrons, which is why we cannot conduct electricity here. Okay, over here you see that sodium chloride has a melting point of 80 degrees Celsius. However, magnesium chloride is a giant lattice as compared to sodium. So it has a higher melting point. So the bigger the lattice, the more the melting point is going to be. This is why, and more because the charges also are increased As you can see in sodium chloride, it's NaCl. NaCl only has +1 and negative bond charges. However, in magnesium oxide, it's +2 and -2. So this is the reason, because of higher charges, they have stronger electrostatic forces of attraction. So substances with an increased melting point, they are called as the refracting materials. And for example, if the magnesium oxide has increased melting point, just if compared to sodium chloride, so it will be known as a refracting material. You can use it in lining of the furnaces and in electrical insulators. And now let's discuss some practice examples so that you have an idea of how to solve. Coming to my first question, the first one says that which statement describes describes the ionic bonding. The A part is a lattice of ions in a sea of electrons. No, this is from metallic bonding. Electrostatic attraction between oppositely charged ions. This is correct. Or the sharing of the electrons, they are not shared. So this is going to be wrong. And then the transfer of the atoms, electrons from the atoms of a non-metal to the atoms of a metal. No, always the metals, they are going to transfer their electrons, and it is always from metals to non-metals. Because metals, they are cations, they always lose electrons, and non-metals always gain electrons. So B is going to be the correct one. Coming to the next one, the diagrams show the arrangement of particles in three solids: krypton, potassium, and sodium chloride. In which order are the solids shown? So you have to tell that which order is it. So if it's going to be this is ionic bonding, right? So sodium chloride is only this krypton is an element, so you cannot go with that. So C or D, either it is C or it is D. Then we have krypton, and then we have potassium. Now potassium is in group 1, so it's going to have its potassium is going to have its free moving electrons, right? So this is going to be this, and then the last one's going to be obviously krypton. So we have 2D. Coming to my next slide. So an ionic bond is formed by electron sharing uh, electron sharing between the metals and the non-metals. So electrons are not shared; they're always transferred. So I'm not going to just think over it more on A or B. I'm going to just switch on to C or D. So electrons, they are transferred between the metals and to the non-metals. So this one is going to be correct. Coming to next question, which diagram correctly shows the arrangement of the ions in a solid sodium chloride? So we just saw the structure, and it's always opposite ions are on similar sides. So if this is correct, that opposite ions, they are going to be on this in this diagram manner. You see here, and chloride. So this one is going to be the correct ionic lattice. So it's going to be 4C. Now coming to my next slide. So why does molten sodium chloride conducts electricity? A. An electron is completely transferred from sodium to chlorine. No. Sodium ions are only weakly attracted. No. The electrons in the sodium chloride, they are free to move, or the ions, they are free to move. So which one is going to be correct in this one? The ions, they will be free to move in a molten state. In a molten state, the ions, the ionization occurs, which is why the ions will be free to move and they will conduct electricity. All right. Then coming to this question, the diagram shows the arrangement of electrons in a molecule of compound YZ2. So YZ2 means, like, if I have to just switch over this, so 2 is going to be 2 will come here to plus, and it's going to be minus, right? Y, it will always be having the positive charge because it is a metal, and Z will have will be the non-metal, so it will be having the negative charge, right? So Y2 plus and Z minus. So Y is going to, carbon has is in group 4. Oxygen is not a metal, sulfur is also not a metal, only calcium is a metal. So, and calcium is also in group 2. So this one Y is going to be calcium and Z is going to be chlorine. It's going to be minus. So chlorine is in group 7, so it is going to carry -1 charge. So this is how you solve these questions. They're very easy, and I hope that you all have got ionic bonding very well, and this is going to be very helpful for you guys. Please practice more papers, and thank you so much for staying with us. If you guys have any questions, please comment down on this video below and I will reply to your queries. Thank you so much, and I'll